Hi everyone. So this lesson is going to be about the tools for measuring electricity. So we're going to have circuits, and then we want to be able to measure the voltage across certain parts of the circuit, and we also want to be able to measure the current going through certain parts of the circuit as well. So I built a circuit here in my virtual circuit construction kit. And the first thing I'll show you is how to measure voltage. So to measure voltage, you have to grab a tool called a voltmeter, which is to the right hand side over here. This is voltmeter. And then I can grab it out. Okay, when you're measuring the voltage, there are two needles, two prongs, where you're going to attach to two parts of the circuit. And then the voltmeter is going to tell you how many volts go across those 2 points in the circuit. For example, I can put them across the light bulb. So one needle there and one needle on the other side of the light bulb. And now this is showing negative 9 volts. So this means that, well, that's how much energy basically each charge is using up as it goes through the light bulb. And we use the language across. Okay, that's a review from the last lesson. I'm measuring the voltage across the light bulb from one point to the other point. I could measure the voltage across the battery as well. So I can move my one needle to one end of the battery, the other needle to the other end, and then I get a reading of 9 volts, which makes sense because the light bulb was using 9 volts. So that means the battery is providing it with 9 volts. So now I'm measuring the voltage across the battery. What happens if I switch the order of the red and the black needles? Well, then this actually says negative 9 volts. All right. And that's because it's kind of hooked up backwards. I do not want you to worry about the positive or negative sign, okay? All I really care about is the number 9. Just know that the battery is providing 9 volts and the light bulb is using 9 volts, no matter whether or not your voltmeter says positive or negative. And that's how you measure voltage. So I have some notes on a slideshow here. So first, what a voltmeter is. There's a definition. It measures voltage across 2 points in a circuit. And I emphasize 2 points. You got to connect it to 2 points. And then the voltmeter should be connected in parallel to the part of the circuit you wish to know the voltage of. So when I connect these needles here, I actually create a second pathway for the electricity to flow through. It goes through these wires. And that's actually a whole new pathway for the electrons. And that's why I say it's connected in parallel, because parallel means separate pathways. Now on a circuit diagram, the bottom of the diagram got cut off a little bit. I apologize for that. But on a circuit diagram, a voltmeter, the symbol is simply just a V inside of a circle. So that symbol replaces this whole device here, the voltmeter. And in my circuit diagram, you see the battery. This menu is getting in the way here. Wait for it to go away. Okay, so there's a single cell battery, and then it's attached to some conductors. And then you have a light bulb here. And now this is how you draw a voltmeter. You can make a new pathway because it has to be in parallel. So this is a new pathway where I attach a voltmeter here, and that measures the voltage. Okay, so that's how you draw a voltmeter in a circuit diagram. I drew a couple of more. In this diagram, I'm measuring the voltage across the battery. So in my circuit diagram, that's where I put the voltmeter. Okay, so I drew this extra pathway parallel to the battery, and then I put my voltmeter in there. All right, the next device is called an ammeter, and an ammeter measures amps. Okay, note the spelling here, A-M and then meter, and that measures amps. And it measures the current, because amps is a measure of current, through one point in a circuit. So ammeters measure how fast the charges are going through the circuit. In an ammeter, you connect it differently than a voltmeter. An ammeter should be connected in series to the spot in the circuit where you wish to know the current. So here's a diagram here. I'm going to build it on the circuit construction kit as well, but this is an ammeter. It's measuring the current. And notice how it's on the same pathway as the thing I'm measuring, which is the current right before it gets to the light bulb. Okay, so I attached the ammeter in series to the light bulb, in the same path as the light bulb. And that's different than a voltmeter. A voltmeter was attached in parallel. So I'm going to show that here. I'm going to put away the voltmeter. And right beside it, I'm going to grab an ammeter. So there's an ammeter. And I want to connect it to this light bulb here to measure how fast, it's going to measure how fast these blue dots are going. So I'm going to click on this connection point and hit the scissors to disconnect it. Adjust the length and the positioning of some of these things so that I can fit this ammeter in there. Oops. There we go. Okay, so in order to connect an ammeter, you have to actually disconnect part of the circuit to open up a spot for you to put the ammeter in. And now that's measuring how fast the blue dots are going. Now, the blue dots, you may notice the blue dots are going at the same speed. Well, pretty much. Okay, it's not like it's going faster in one spot of the circuit and slower in another spot of the circuit. They're going at a pretty constant speed all throughout. So that means if I measure the current somewhere else, okay, let's say I measure the current right at, I'm going to break up the circuit here. I'm going to put the ammeter there. And the value it gives me is 0.9. That was the same as when I had it connected to the light bulb. So what I'm trying to say is that the speed of these blue dots are the same everywhere. You're going to get the same reading. However, you're going to get a different reading in a parallel circuit. Okay, parallel circuits are going to be a bit more complicated. So I'm going to make a parallel circuit. So just bear with me for a minute here as I make a parallel circuit. So remember, a parallel circuit is a circuit with multiple pathways. So I'm building one pathway right now. And then I'll build the second pathway after that. All right, so here's one pathway. This is not a light bulb, this is a resistor. A resistor slows down the electrons. And now I'm going to build a second pathway. And I'll put a couple of light bulbs in the second pathway. I'm going to put 2 light bulbs in the second pathway. So now this is a parallel circuit. And in a parallel circuit, the currents, or that is the speed of the blue dots, is going to be different for different parts. So where are the blue dots going faster and where are the blue dots going slower? You may notice that the blue dots are going fastest in the bottom line where the battery is. And they're running a bit slower in the middle line where the resistor is. And they're going even slower in the top line where I have 2 light bulbs. So that's because 2 light bulbs offer a lot of resistance to these electrons, so it's going to slow them down more. So to show you the values, what I'm going to do is attach ammeters. So I break that apart, grab an ammeter, put it in there. So it says it's 1.35 amps going through the battery's path. That's how fast they're going, 1.35. Then I'll try the resistor. I'll add another ammeter there. Okay, and it's showing 0.9 amps. So as I said, and as you can see, these blue dots are a bit slower than the blue dots going through the battery. And finally, the slowest ones are at the top here. I'm going to unhook that. And I'm going to put another ammeter in. And now you can see that that is reading 0.45 amps, so even slower. Okay, so that's how you connect an ammeter to a circuit. You have to connect it in series. That means you have to disconnect part of the circuit and then insert the ammeter in there. And just for fun, I'm going to review the voltmeter. So if I want to know some voltages, let's look at the voltage across the battery first. So the battery is 9 volts, giving out 9 volts of energy. I'll look at it across the resistor now. So the resistor is also 9 volts, so it's actually using up 9 volts of energy. And I'll do it across a light bulb. So one light bulb is using 4.5 volts. The other light bulb is also using 4.5 volts. Now watch this. I have one prong on one end of one light bulb. I'm going to put the second prong on the other end of the other light bulb. And now it reads 9 volts again. So I'm measuring the voltage going across 2 light bulbs at the same time, or 2 light bulbs in total is using up 9 volts. I've got a diagram of this circuit. Well, first of all, this is a simpler circuit, just one light bulb. And I've got the ammeter in there right beside the light bulb. And the circuit symbol for an ammeter, actually this here should say ammeter. I'll change that on the slides for you so you have accurate slides. The circuit symbol for an ammeter is just an A with a circle around it. And if I want it beside the light bulb, like I have it here beside the light bulb, all I do is draw the circle with an A beside the light bulb there. And this was the complicated circuit. I had the resistor in the middle. Okay, just a reminder, a resistor, the symbol is a squiggle or a zigzag. Zigzags for a resistor. Got the 2 light bulbs at the top, which I've drawn here. Got the battery at the bottom. And I drew in 3 ammeters. Right, I've got an ammeter in each pathway. So I have 3 ammeters, 1, 2, 3 in my circuit diagram. All right, so that's how you connect voltmeters and ammeters to measure voltage and current. These slides are available to you on Google Classroom. You also need to know how to draw them in a circuit diagram. And we're going to put it all together in an assignment at the end of the week. However, I want you to start by practicing. So going back to the Google Classroom, there's a hand-in folder for ammeters and voltmeters. And I just want you to practice drawing circuit diagrams and hooking these things up. Get some feedback, make sure you get it right so that you're going to be ready when the time comes to do the assignment at the end of the week. All right.